Hello and welcome to this video for beginners who are interested in getting started with Kaggle. My name is Kaiwen Liu. I'm a second-year master student studying statistics and data science. Today I'm very excited to share with you about Kaggle. So basically there are two parts in this video. First, I'll give you a brief introduction to Kaggle, which includes how to join a competition and how to create a notebook in Kaggle. I'll also show you an example of doing that. And the second part is about a project I did using Jupyter Notebook. In this part, I'll talk about the basic procedures of doing a machine learning project. Okay, so what is Kaggle? Kaggle is a community and platform for data science and machine learning enthusiasts. It's like a large hub where you can find all sorts of stuff from data sets to competitions to code examples. Okay, now let's get into Kaggle. The first thing you want to do is to create a account of Kaggle. So by clicking on register, you can create a Kaggle account by using by register with Google or your email. Since I have an account, I just need to sign in. Now I have entered into Kaggle's page. So you can notice there are a bunch of tabs on the left side. These are different features of Kaggle, and I want to talk about the datasets feature first. The dataset is a great feature in Kaggle where you can find a lot of datasets, and they are usually gathered under a certain topic, like biology, social science, automobiles and vehicles, investing, and so on. And you can also click on the tabs listed here or search a tab that you are interested in. Now let's enter into like if I'm interested. Let's say I'm interested in arts and entertainment, and I want to see all those datasets listed under this topic. Then I need just click in, and I can even rank these lists by. You can click here the relevance. So it is now ranking by relevance. You can also rank by most votes. Then we'll list the most upvoted datasets in a descending order. Now, if let's say I'm interested in Disney Plus movies and TV shows, and after clicking, the first thing I notice is there is a data card. It talks about the basic information about this dataset, where this dataset comes from, and what the content is. And you can also notice there is a CSV file and basic information about this file, the columns, the yeah, it even gives you some statistics of each variable in this file. And if you're interested in this file and want to do something to this dataset, you can download this dataset by click on the download here. And if you find this this dataset useful and you want this dataset to be seen by more people, you can upload it, and you can also create a new notebook based on this dataset. And now let's see. So there's a code section where you can find other people's work, other people's notebooks. Here, you can also rank this. If there are a lot of notebooks, you can rank these notebooks by most votes. And then there is a discussion section. Well, usually there are people's posts about the questions on this dataset, or people just looking for like teammates to work together on this dataset and things like that. Okay, now let's go to competition section. So competition is also a great feature on Kaggle. Um, as you can see, there are a lot of competitions that are sponsored by companies, and these companies usually they give a lot of money, and it also gives you it also labeled under different topics. So let's say if I'm interested in this topic, this competition, after I click into this, the first thing we would like to do is browse this overview section. Well, it talks about the basic information about the competition, the goal of the competition, the context, and next thing is evaluation. So this is about the how the result of your work is going to be evaluated. So the submissions are evaluated on SMAPE between forecast and actual values. This is the requirement of this competition. So the basic goal of a Kaggle competition is to develop the best machine learning model that can accurately predict or classify a specific outcome based on a given dataset. So the next tab is about timeline. It lists all important dates during this competition. And the next tab is price. It tells you how the rewards is going to be allocated. And the final tab is code requirements. It requires how your code should be written. For example, it asks you that submission file must be named as submission.csv file. So you definitely want to check these requirements before you get started with your work. And next tab is data. So it gives you the basic description about the dataset. And the next tab is code. It's pretty much like the sections we talked about in datasets feature. So it also gives you a bunch of users' notebooks, and you can also rank them by most votes or other labels. And the discussion tab is also lists users' posts, and sometimes you can find a post like looking for a team, make thread, look for teammate post, things like that. Yeah, so this is a great place to work with, to look for partners and work with other machine learning users. And you can also find some really useful resources like a guide to competition metric, patient level time series feature engineering, things like that. So if you are really interested in this competition and you decide to join this competition, you need to go to the rules section and click on this I understand accept button. It means you are officially in this competition after you accept these rules. And the leaderboard is where it shows the rank results. Okay, so next thing I want to talk about is, well, I'm not familiar with model sections, so I'll skip it. Code section is, well, it gathers or all users notebooks, and they are labeled with different topic labels, like clustering and biology, pandas. It's pretty much like the dataset feature. So the discussion section is another entrance to like I talked about in datasets and code discussion tabs. So yeah, you can find very useful posts here with different labels. And the final section, I want to recommend you to take a look, especially for beginners, is Learn section. So here Kaggle provides you a lot of courses where you can explore like programming, SQL, time series, data cleaning, and talking about machine learning. And there's a guide I highly recommend you to check out. There's a Titanic machine learning from disaster for beginners. So it's a tutorial about how to join in a competition. It's pretty beginner friendly. Okay, the next thing I want to talk about is create a notebook, and I'll use competition dataset as an example. So it's called house price competition. So this is competition also for beginners. As you can see from the description tab, and now I want to join this competition, which I've already done. So now the next thing I want to do is create a notebook. So click on the create button and click on the create a new book. Now I have entered into the Jupyter Notebook page. So basically, Kaggle provides a cloud-based Jupyter Notebook environment where you can write your code here. So the first thing I want to do is add the data from that my house price competition. So you click on the add data, and you need to search your competition. Now it's added into your input file, and you can find the file here, and by click on this copy file path, you successfully copied the file path. And I'll show you an example of how to import the file. So basically, you can write a function. I remember it's from pandas library. There is a Redis CSV file. So you just need to paste the path here. And click running, which is the small triangular tab here. Alright, before doing this, we need to import the library. So I should first run this section, and then you can use this PD library. Now it's successfully um, read into environment. Yeah, that's basically the procedure of importing the data file. Okay. Once you've done your work, you can save the version by click on this. And there are two types of saving. So first is save and run all. So it will run all the tabs um, in your work in your notebook, or you can just quick save. It will not run your all the work. So if your notebook includes a lot of moral training, or it will train for a very long time, you can choose quick save. And we just wait until it is successfully saved. So in the second part, I'll be introducing you to a project I did based on a Kaggle dataset, which is about diabetes of 130 U.S. hospitals from year 1999 to 2008. So I'll first go to the notebook I created and upload it to the dataset code section. So in here you can find the notebook I created. Um, I I can show you the basic procedures I did. So this is the structure of my notebook. I'll start with introduction. So this is a data set that represents 10 years of clinical care at 130 US hospitals and integrated delivery networks. It includes over 50 features representing patient and hospital outcomes. Information was extracted from the database based on the following rules. And before going into detail about my work, I need to talk about the objectives. So there are two objectives. First is to obtain a useful and efficient model to predict on whether diabetic patients will be readmitted within a month. And the second target is to find out what features are the most important in readmission of diabetic patients. This is important because some clinicians need to tell if a patient would be readmitted within 30 days based on demographic information of that patient and other medical specialty change. So this can help clinicians to determine if a patient will get another extra medical support or interventions, and help clinicians to allocate those medical resources more scientifically. And then I list a bunch of features and their description. Yeah, so there are over 50 features in this dataset, and the response variable, well, the original response variable has three categories, which is readmitted within 30 days, readmitted over 30 days, and no readmission. But I turned this into a binary classification problem, by which I mean I only set two categories, which is readmitted within 30 days and other group. So I combine the over 30 days and no readmission into one category, because I I'm only interested in whether patients will be readmitted within 30 days. Honestly, at first I thought it should be a classification problem with 3 categories, but the result of doing that is not ideal. So I thought maybe I could treat it as a binary classification problem since there is a large variability in group of no readmission and the group of readmitted over 30 days. So, for instance, in group of readmitted over 30 days, I don't know how long it would take for patients to get readmitted. I mean, is it 31 days or is it a year or several years? So there's a large variability in that. And in no readmission group, um, occasions may appear that a patient did not get readmitted, but it um, happened in another hospital, which did not get recorded in the system. So I finally decided to make it a binary classification problem, and I will only be interested in whether a patient will be readmitted within 30 days. And it turns out the result is pretty good in terms of classification, 3 categories. So next step I did is doing some preparation steps. The first step I did is to import packages and load data. So there are a few packages I would like to talk about. The NumPy, Pandas, and sklearn are very often seen in data analysis projects. So NumPy and Pandas are very useful Python libraries. Um, they provide a lot of functions by which you can use to manipulate data, manipulate like matrices and arrays. And sklearn, this is about it provides a lot of functions dealing with modeling and like and functions like training, test, split. So it helps you to split a data set into training and testing. And there are packages like matplotlib and other very useful packages you can explore on your own. And in this step, I load the data, and then I start doing some operations on the data. So I did drop dependent observations. So in the original data set, there are a bunch of observations. They have the same patient ID. So in terms of removing the dependence among the observations, I remove these duplicate observations uh, by their patient ID and kept only one unique patient ID that appears at first in the dataset. That's what I did in the drop observations step. And by the way, I created a class named drop observations here. So this is a technique I used in order to building a pipeline. So at the end of all these operations, I built a large pipeline which includes all these operations together. So in order to make this notebook looks more tidy and clean, and it could avoid doing the same operations on the test data again. Yeah, it will save you a lot of codes and can make your code easier to read. And next step I did is split dataset into training and testing. So by using function from scikit-learn, I can directly split the original test data into training and testing. And the next step is about data processing. Next step is about data preprocessing. And the first thing I did is impute gender missing values. So I customized my imputer class that extends base estimator transformer mixing from sklearn pipeline package. So I did this mainly to let this class be integrated into the final pipeline. And in order to implement these two class from scikit-learn pipeline package, I need to implement two functions, which is fit and transform. So basically, what the underlying principle of fit and transform is that fit stores the information you extracted from X and Y, and you can store those information in the variables you created in my imputer class. Let's say here, I created a column variable which stores the column names of the variables and missing values and some other variables that you will use later in your transform function. So let's say there is a training set and a testing set. The first thing you would do is you create an object and use fit function to fit your training dataset, and this means you extract some information from your training set and store the information into these variables. And later, when you want to transform dataset, when you want to transform the test dataset, you are using the information extracted from the training set here, and use that to transform your test dataset. That's the underlying principle of fit and transform. Okay, and the next step I did is group ICD-9 into categories. So ICD-9 is a medical code system, and for different codes, it represents different kinds of diseases. So I need to group these codes, like from 390 to 459 and 785. These codes represents that this disease is kind of a circulatory disease. So I need to turn these codes into a category. Yeah, that's what this class is doing here. And the next thing I did is drop unnecessary columns. Drop features. I also define a class. So I define all of these operations in order to later let them be integrated into a pipeline. And after doing that pre-processing, I did feature selection. So basically, I used chi-square test to to get all the features that have significant correlation with readmitted with the response variable. And if some features they don't have significant p-value, I directly drop them. So that's basically drop feature without chi-square, with low chi-square p-value is doing here. And in this encoding Kaggle features, I encode those categorical variables into dummy variables. That's what it is doing here. And in the final part, this is about modeling. I chose 3 models: random forest, XGBoost, and logistic regression model. And before doing that, I first created a pipeline for preprocessing, and as I said, it includes a lot of operations. So this is my imputer objects, group ICD9 into categories objects, job features object, and so on. This can ensure the code to be simpler and easier to read, and it will help you avoid many repetitive work. And the next thing I did is fit the random forest model. So first I imported a random forest classifier, and I set a parameter grid. So it means I will search a best parameter, a set of parameter among these parameter combinations, and I use grid search to do that. This is provided by sklearner package. And after I fit the data and get the best parameters, I can print the best parameters, and this is best random forest model, and I use that to get a score, get a accuracy, get a training accuracy, and then I can predict on the test data set and also get a testing accuracy. And the final step is about create a plot of 10 most important features, which will be useful for clinicians to determine like whether a patient will get more resources in terms of a certain like diagnosis or medicine, something like that. And in XGBoost, the same steps applied here. Yeah. And it, same also done for logistic regression. And for the final part, I wrote a conclusion. So it briefly talks about the procedures I did above, and made a little conclusion about which model is best. But it turns out they both have a higher accuracy, like 92%. But I would recommend using logistic regression model because it is more easier to interpret. And I think there are still a lot of things I need to improve in terms of this notebook. Like if I have domain knowledge in medicine, I would probably interpret more on the final result, like analyze which diagnosis, which medicine that we should focus on. Yeah, things like that. yeah, so that's basically it. That's basically the whole procedure of my project. And thank you for listening, and hope you found this video helpful.